SedLine brain function monitoring. We know you're committed to patient safety during critical care. At Masimo, so are we. For clinicians who want to continuously monitor their patient's brain under sedation, SedLine makes it simple, providing an array of real-time data to arm you and your staff with the tools you need to make effective care decisions. SedLine brain monitoring data is displayed en route, which combines a high-resolution screen with built-in network connectivity and third-party device integration. The SedLine data displayed en route is divided into 3 sections. First, at the top of the screen, you'll find EEG tracings that represent the EEG activity on both sides of the brain simultaneously. The Patient State Index, or PSI, is a numeric value between 0 and 100 related to the anesthetic depth of your patient. This number is derived from SedLine's computational analysis of EEG patterns and features. The PSI is trended over time alongside other parameters, including electromyography, suppression ratio, artifact, and spectral edge frequency for both the left and right EEG. Finally, the colorful graph displayed at the bottom of the root screen is the density spectral array, or DSA. The DSA contains left and right spectrograms, representing the power of the EEG on both sides of the brain within specific frequency ranges. Independent of the PSI, the DSA provides another interpretation of EEG. Let's dig deeper to understand how the DSA is formed. With SedLine, both the PSI and DSA are derived from EEG patterns and features using computational analysis. Here's an example of EEG patterns in patients who received anesthesia, ranging from light to profound depths of sedation. By examining the different speeds in the EEG and performing frequency analysis, while measuring the power of the EEG signal in each of the frequency bands, SedLine constructs the DSA, a frequency power analysis over time. Let's consider an analysis of a single lead of EEG and graph the amount of power in each frequency. Then we can consider the power of these frequencies and use colors to grade their relative power. Warm colors are used for higher power frequencies, and cooler colors are used for lower power frequencies. Imagine that the graph is reoriented and constructed every 1.2 seconds. Then, reorient it again. We can begin to see the DSA take shape. By calculating where the power is in the EEG, SedLine can display the spectral edge frequency, the level at which 95% of the power exists, and plot it as a white line on the DSA. The resulting display provides a power and frequency analysis over a 20-minute period, a density spectral array. Looking at the DSA, it is easy to determine whether the left side of the brain has similar frequency and power to the right side, and where the spectral edge frequency is and has been. It is also easy to check whether there is burst suppression in the DSA, because SedLine places a black vertical bar with a blue tick on the DSA whenever burst suppression is detected in the EEG. Understanding how to properly interpret the DSA can enable clinicians to easily identify the spectral features of anesthetic-specific signatures and estimate patients' level of sedation, and help improve patient outcomes. For more information on SedLine, visit massimo.com/sedation or contact your local Masimo representative.